So let's get into that unit where we're talking about chemical reactions. And in chemical reactions, I want us to see that there's a before and after effect. We've got reactants on the left and products on the right. And I draw an arrow sign. What does that mean, the arrow sign? Yields. Okay, so let's write this down maybe in there that means yields. In other words, produces is another good word. So your reactants build your products. So in the case of the quesadilla, that was Jason that said quesadilla, correct? What would be some of the reactants in the quesadilla? Cheese. Good. What else? Tortilla. Right. So those would be your reactants and your product would be the quesadilla, correct? Or in the case of my sandwich, the bread and then the bologna, and then you have your sandwich, right? So your reactants and then your products. Agreed? Now, what can we say about keeping everything normal, about conserving our stuff? For instance, let me ask you a question. What if I took the mass of my 2 slices of bread and my slice of bologna, and I added them up and I got a mass of, let's just say 100 grams? What should the mass of my sandwich be then? 100. So the mass of your reactants and your mass of your products should do what? Should be the same. In other words, they should equal the mass of the products. Cool. I think we like that. That makes sense. So maybe in an example, a poor example, but I'm still going to give you the example anyway. If you start out with 2 breads and you add 1 meat, what can you have 1 of? This isn't a difficult question. 2 pieces of bread with a piece of meat in between, what is it called? A sandwich. And a sandwich is made of 2 breads and a meat, correct? Isn't that what a sandwich is? 2 breads for every 1 meat? Do you see how I've put the 2 in front on this? I've put those numbers in front. I'm doing that to conserve my mass. I'm doing that so that my reactants and products are equal. There's 2 breads over on the left side. There's 2 breads on the right. 1 times 2 is 2. How many meats are there on the left? There's just 1 meat. How many on the right? Just 1. There's no number after the M. Question?
Wouldn't it be the same if the 2 was in front?
Over here?
And on the other side?
On this side.
Yeah, if it was on the other side, would it be the same?
Yeah, I mean the two there and then the 2 there accounts for 2 breads on both left and right.
So can you put the 2
In front, right there.
on the reactants?
Put it on a little 2 right there
Yeah.
instead of having it right there.
Yeah.
Well, let me ask this question: are those 2 pieces of bread independent of each other initially in the loaf? Right. You can get them out one at a time, so you put the 2 right there. Right. So go ahead. I'm sorry. No, you don't have to write ones. Just like in algebra, you know how when you solve an expression like 6x is equal to 24? Y'all know how to do this, right? Divide both sides by what? 6, and then you get x is equal to what? You can write x equals 4. You don't have to write that 1x is equal to 4, correct? So it's the same principle. You don't have to write ones. It's understood. What you're seeing there, these numbers in front, they're called coefficients. They are added in, as you can see, to balance a reaction. But you'll notice that I'm not really talking about a chemical reaction here. I'm just talking about a reaction that I had about every day over the break, which was me making a bologna sandwich, because we're in a recession. So let's talk about maybe making a real chemical, maybe doing something in real chemistry. So let me give you an example real quick. A pretty straightforward example. This right here is the synthesis of water, H2O dihydrogen monoxide. You take hydrogen, oxygen, and make H2O. Cool? Now let's watch this. Let's balance this expression. This 2 right there affects the H. How many H's do you see on this left side? See 2 H's. How many H's do you see on this side over here? 2. This 2 affects only the number that's directly to the left of it. How many O's are on the left side? How about on the right? Only 1. There's not a number down there, is there? So that means it's kind of an understood 1. So again, Quabi, how many oxygens are on this left side? On the right side? That's going to be a problem. So here's what I'm going to do to solve that, or to fix that, alleviate that concern. I'm going to put a number, because you can only add coefficients for now. I'm going to put the number 2 right there. Now a coefficient, which we added to balance the reaction, we've just done that, affects everything after it. So how many oxygens do you see over here now? 2. Which is great because there was 2 on the left. But how many H's are there now?
4.
And yeah, you've kind of caught the trick that that's a little bit difficult to teach sometimes. The effect that both these 2's have in a multiplication setting. 2 times 2 is 4. There's 4 H's on the right hand side. So what number do I have to add right here? A 2. And we're balanced. Because 2 times 2 is, of course, 4 H's. Good? So we've balanced the expression. Do you mess with those little baby numbers? No, they come from crisscross. If you remember from back in the day, like if I said magnesium fluoride, you'd write Mg 2 plus, F 1 minus, you do crisscross and get MgF2. You write the baby numbers because of that. You don't write little baby subscripts because you want to balance it. You write coefficients to balance. Cool? Why can't there be a 2 over here, baby 2? Because H2O2 is not water. H2O2 is hydrogen peroxide, and that'll kill you. Seriously. So there's, you don't start adding the little baby numbers as you want to.
So it'll tell you what to find.
You'll need to, you will balance equations based on putting big numbers in front, coefficients. Yes. Good? Let's look at another example. I'll give you one more. I'll let you write this down real quick. We'll leave blanks up front. Let you copy this down real quick. Magnesium fluoride plus aluminum phosphide produces aluminum fluoride plus magnesium phosphide. Now, as you work through these more and more, you'll see that there are different little tricks that you can institute. One of the major tricks I think that we could utilize is making sure that we always balance metals first. So let's use that trick to our advantage real quick. How many Mg's are there on the left? And then how many Mg's are on the right? Is 1 and 3, or are those the same number? No. So Channing, what do you suspect I should put right in this blink right here? A 3. Perfect. Now I want us to follow this, so I'm gonna let you write down the 3, and then I want to take this a step further. 1. How many fluorines are there now on the left-hand side? There's 6. There used to be only 2, but now you've got 6. Okay. So a fix for that would be to make sure you have 6 fluorines on the right side. So Diego, what number do I need to put in front of this AL right there? A 2. Great. That makes how many fluorines on the right-hand side? 6, just as you're supposed to have. But you'll notice that what did you just change putting that 2 there? Aluminum. How many aluminums are there on the right-hand side now? How many are on the left? So what number do I need to put here?
So you don't even need that last line.
You don't, because putting a 2 there makes 2 aluminums, which is great. Makes 2 phosphoruses, which was already on the right-hand side. Don't need to write a number there. If you choose to write 1, I guess that's fine. What do we think? Not overly difficult. You know, if you're thinking about making a sandwich yourself when you go home, and you're thinking, I want 1 sandwich, in your head you're thinking that's 2 slices of bread, so I need 2 slices of bread out. It's the same concept. We're just not making sandwiches in this class because this isn't Subway. This is Mr. Field's chemistry classroom, so we're going to use chemicals. Good. Jason, what do you think? You like this? I see the excitement. Okay. So we'll keep this going. Let you copy down this problem real quick. Okay, so what we have here is we have this reaction. So let's start this out. Jennifer Estrada, how are you? Good. How many calciums are there on the left side? I'm sorry, what? 1? Okay. Grayson, how many calciums are there on the right side?
1.
So calciums isn't a problem. I'm not going to add any numbers to this. Nicholas, how many magnesiums are there on the left? And then on the right? I don't need to add any numbers there so far. So I just need to check out my N's and my O's and my C. So let's start with C, which is carbon. Can someone tell me how many carbons I have on this left-hand side? Just 1. Just 1 carbon. That 3O is only for the oxygen. 1 carbon on the left-hand side. How about on the right-hand side? Only 1. Okay. Eric B., how many nitrogens are there on the left side? The 3 right here is only for oxygen, but that 2 is for nitrogen. So how many nitrogens are there? 2. Let's make sure we catch that 2 in the parentheses system, that 2 applies to everything in the parentheses. So there's 2 nitrogens on the left side. How many nitrogens are there on the right side? 2 there as well. Do you see that 2 right there? 2 nitrogens on the right-hand side. Good? Okay. Now let's check on oxygens, and this one's one we want to be careful about. How many oxygens do you see on the left-hand side? Careful, you've missed it. There's 9. 2 times 3, that's 6 there. Plus these 3 is 9. Did you catch that? There's oxygens in both compounds. How many oxygens are there on the right-hand side? 2 times 3 is 6 there. Plus 3 there is what? So the oxygens are balanced. You don't need to write any numbers on this one. Good? Okay. I'm going to get you to work on this one real quick with someone around you.
Is it ever gonna,
Sir?
is it ever gonna be possible that there's nothing to do?
Yes, just like on that one.
Or like not nothing to do, like there's
It's impossible. Yeah, I mean, honestly, there is, but I would never give you one that's like that. At least I don't think I would. Sorry, that didn't stay all on the same line. But there's your 2 reactants and then your 2 products. Cool. And let's take just a couple of seconds, maybe 40 seconds, to solve this one real quick. So looking at question maybe 18 to start us off with real quick, you'll notice that I've given you 2 reactants, correct? You have your 2 reactants right there. And then I've given you 2 products with the ZnCl2 and the H2. Agreed? I'm giving you 2 reactants and 2 products. Question 18. What should their masses be? Equal. So with that statement, what this means is that 65.4 plus 73 should be equal to 136.3 plus my question mark. Well, the question mark's like saying x, a variable. I'll let you solve this with your algebra skills real quick and your calculator. Everyone needs to have a calculator. If you need a calculator, let me know. I've got some. Good. I got these 2. You can borrow. Okay. I think actually, guys, I only have 2. I'm sorry. I don't know where my other ones are at. I'll find them for tomorrow for sure. What do we get x to be? 2.1. That's the number of grams of H2. Right? Just to make sure we're 100% set, I'll let you solve 19, and we'll solve it. I'll let you solve it real quick, then we'll check it, and then that'll be the end of it. So solve 19 real quick. Tell me what P2O5 is equal to in grams. Let you write that down. What do we get the amount of grams was? 283. Very good. So is that what everyone got? Brian, you said? So in a summary for 18 and 19, we just need to remember that reactants has to equal what? Your products. You got to conserve the mass. Law of conservation of mass. Cool. Let's look at number 15. You'll see that in 15 and 16 and 17, your responsibility with applying naming rules, which is something we went over like in November, is not diminished. It has not gone away. And so you remember, and I kept saying this, and you're like, Mr. Fields, go play some Justin Bieber because you're not being serious. I was serious at that time. I said, if you can't name, this will be a problem for the rest of the year. And you can see it still is. So let's work out 15, maybe 16, and then 17 you'll be on your own. Tell me, calcium, what is that? Ca. That's not a problem. Reacts with, that's going to be plus. Hydrochloric acid, what's that? So that would just be HCl. To produce hydrogen. Now I'll give you a little hint on this, and we'll talk about why this is the case more so tomorrow. But hydrogen is going to be H2, and I'll talk tomorrow why there's a 2 there. And then calcium chloride. Calcium is what? And chlorine chloride, Cl. But I've got to remember to put my 2 plus. And what's chlorine's charge? 1 minus? How do you know that? That 2 plus 1 minus situation. That's magic, right? No, it's just periodic table stuff, right? You do crisscross, and what is that? Ca Cl2, because that 2's coming down. You got to remember this stuff, right? Okay. Now we bounce. How many CAs are on the left? 1. CAs on the right? 1. That's not a problem. How many H's are there on the left? That's not a problem. On the right? That's a problem. What number here? But doing that just changed up what else? Yeah, how many Cl's are on the left now? So on the right? You'll see it's balanced. Good? Now we're doing some real chemistry. Okay. Wait till we add moles to this. That'll be fun. Sodium chloride. Okay. Sodium chloride. Sodium is what? Na. What's its charge? 1 plus. Chloride. Cl, and it's 1 minus, right? So that's going to be NaCl. Reacts with silver nitrate. Now, the hint that they gave you was that silver has a +1 charge. Silver is Ag with a +1. What about nitrate? That's a good one. Does anyone remember that one? Oh yeah, NO3, 1 minus. You do crisscross to that, and it's just very good. AgNO3. To produce sodium nitrate. What was sodium again? What's its charge? +1. Quabi, what's nitrate? Very good, and its charge? 1 minus. So we do crisscross to that, and what is our sodium nitrate? It's NaNO3, right? With silver chloride. Silver's charge was what a while ago, Brian? Uh-huh. Very good. So Ag1 plus. And then Jennifer L., can you tell me what chlorine's charge is? Very good. Cl1 minus. And we do crisscross that, and we get AgCl, right? Okay, Breslin, let's do this. How many NAs on the left?
1.
Right?
1.
Silver's on the left. 1. Silver's on the right.
1.
You'll notice I started out with the 2 non-metals or the 2 metals? Always metals you start with. How many chlorines are there on the left? On the right? That's not an issue. How many N's on the left? 1, right? On the right? Oxygen's on the left. Right? It's already balanced. You don't need to add any numbers. Good? 17 you'll work out on your own. Now let's jump to the front real quick on some of these problems. And let's say, maybe I'm going to get you to work on like the first 3 problems with someone, and then we'll check them. And let's say you have 3 problems in 3 minutes. You are welcome to work with a partner, a friend, a buddy. Work from the perspective of nothing's been filled in. So there's 2 nitrogens on the left side. What number needs to be added to that NH3? A 2, right? And that would make 2 nitrogens on the right-hand side. Well, doing that makes a total of how many H's on the right-hand side? 2 times 3 is 6, so you'd have to add a 3 there, and you're balanced. Now, you can leave it like that, or you can write the 1 in there, and I don't care. I just don't care. Simple enough. Okay, how many K's on the left? Always start with metals. 1. K on the right. That's not a problem. Let's go to CLs. How many CLs on the left? On the right? 1. Whoa, what? 2? No. There's 1 CL on the right. So K's and CLs aren't a problem, but O's are. There's 3 O's on the right, or I'm sorry, on the left, and then 2 O's on the right. So to fix that, I think we would think, well, putting a 2 there and a 3 there would make 6 O's on the left and 6 O's on the right, which is great. But you've also messed up your K's and CL's in the process, so make sure you put a 2 in that middle blank there, because I think I saw some of you guys forgot to do that. Make sure you put that there. Number 3, how many NAs do we have on the left?
1.
On the right?
1.
CL's on the left. Not everyone at once, please. 1 on the right. Okay, so I need to put what here? 2. How many NAs now? 2 on the left, right? So 2 there. It's all balanced. What do we think? Raise your hand if you're like, I get this, we're not having problems right now. Okay, raise your hand if you're like, mostly good. Raise your hand if it's not, if it's sad face. Raise your hand if sad face. Okay. Well, let's keep working on this real quick. Let's look at 4, 5, and 6. And here's what I want you to do. I want you to work on 4, 5, and 6, and I want you to work with someone that is not by you, someone that is across the room from you, and I want you to work somewhere in the back or around in the front. So I want everyone moving, and I want you guys to be working together on 4, 5, and 6. You don't need to pack your stuff. Just go somewhere. Not out of the